Hi all, welcome back to software testing course. So in the last class we had seen testing approaches. We had seen static versus dynamic, top-down versus bottom-up approach, then positive versus negative testing, function versus structural. In that we had seen path coverage, statement coverage, then condition coverage, and also about function coverage, right? Next, we will see about structural testing at integration level, then at the system level. So, how do you do the structural testing at integration level? So, structural testing is nothing but your white box testing. Code comes into picture, right? So, how do you do that? So, we will consider the various modules of the e-learning portal. Let me get you the e-learning portal diagram. Yeah. So this was the e-learning portal, right? Integration testing, we had seen this example. So basically you had three main modules, which is admin, tutor and student. Then we had submodules for each of those module, right? So for consider for example this student module. So how do you do the testing of this one? First we do the independent testing of these submodules. Then we do the uh, we do the main module testing later. First we'll do the independent submodule testing. Say for example here you have online test, right? How can you test this module whenever you don't have an online test, or whether the online test is not created? Who has to create that online test? It is tutor module, right? So whenever you want to test the student modules online test submodule, first you have to make sure that in the tutor module you have online test allocation submodule, and this has to be tested first. Then only you can test student modules online test submodule. Correct? So at a testing level, we need to consider the structure of the modules for finalizing the strategy. So for strategy is like the same thing, whatever we discussed, how to test this particular submodule without having this particular module created, right? So next we will see structural testing at system level. Structural testing at system level means application as a whole. Okay. So when you consider the structure of the system level, you look at the major modules in the total system. So for example, in the e-learning portal, the main modules were admin, tutor and the student, right? So you can start testing the student modules, then the tutor and then the admin module. So in case of a web page, what will happen? So you have a home page that gives you overall structure of the web page, right? Like the main links, buttons. So these all things has to be tested. So whenever you click on each link, you will get, or you get to the sublinks, or you can go to the different page. So in the top down structural testing, you can begin at the home page and go down the leaves. That means from the home, go to the next page. Likewise, you can come down till the last submodule. So here you can see, right, in this diagram, the home page of a website that provides weather of India. Okay, so you can easily make out the structure of this website. Like you have three links over here, right? You have three links for weather resources. Then you can search something. You can see the major cities and get the weather of that one. So once the overall structure, you know about the overall structure, you can click on each link and get the internal details. So after overall structure is obtained, you can start testing from the home page. That is your top down approach, or you can start from the bottommost links. So that is bottom up approach, right? So that is about structural testing at system level. Fine. Next, we will talk about black box testing versus white box testing at code level. So, your both black box testing and white box testing have to be done for every software package. Okay, and white box testing, it presents some advantages in this, detecting your defects as well as reducing the testing time and effort. Say we'll consider an example wherein this is a function, and if x is greater than 0, it returns abc, that it returns one function abc of x, otherwise it returns another function result, that is pqr of x. So here the return value abc of x, if x is greater than 0, and return value is this one pqr of x if x is less than 0. So when you are doing a black box testing, that means the function testing, since you do not know the structure of the code, you don't know how this is implemented and all. Okay, so how you do testing in that case? So you just give values for x. Okay, x is greater than 0, x is less than 0. You give different values for x and then you test it. So, but in white box testing, what you know the internal structure. That means you know how the function is working, whatever has been written. So you know the code details. So how can you test it then? So you know whenever x is greater than 0, it would be ABC of x function would be called, and whenever x is less than 0, it would be PQR of x. So you can test thoroughly ABC of x function for x is greater than 0 and PQR of x function whenever x is less than 0. So hence in a white box testing what will happen is we save a lot of time. In the black box what we were doing? We were giving value for x like x is 1, 2, 3 like this we were giving. Again -1, -2 something like this we were giving. We were trying different combinations of values of x. But in the white box testing we are directly giving some random values and we are checking, right? Again, so in the white box testing, it helps you in finding out whether the programmer has made any mistakes at the boundary conditions or boundary values of the loops. Say for example, consider you have a for loop wherein I is equal to for I is equal to 0, I less than or equal to 100, and I plus plus, something like this. It has been given. So whenever you execute this loop, it would be executed 101 times, right? So I had taken for I is equal to 0, I less than or equal to 100, then I plus plus. So this loop would be executed for 101 times. So in this case, you might be in a confusion like the programmer really want to execute that loop for 101 times or he has made some mistake. So it could be like the programmer has made some mistakes during the boundary values, right? So the testing has to be done at the loop boundaries. Okay, so it is I less than or equal to 100, right? So you have to make the boundary value testing here. So this type of testing cannot be done through your black box testing. And when the functionality is not met, debugging is extremely difficult, and when only black box testing is done. Next is mutation testing. So this mutation testing is required to ensure that the software does not fail. And this mutation testing comes into picture once you have done your system testing. So you know your system is working correctly, then you can have this mutation testing. Okay. So what will happen in a mutation testing is like your logic. It is changed, program logic or the code logic. It is changed slightly to obtain the mutants of the program. Say for example you have a application where say suppose you are doing addition of the numbers, so you change that operator with some other operator, and that time what you have done is like you have created a mutant of your original program. Okay, now the different mutants, these have to be, you have to create multiple mutants. Okay, and these mutants, whatever the new code pieces you have created, on top of that you have to execute your old test cases. So if the mutant fails, that means the actual program it is working correctly. So whenever it is working correctly, you gain the confidence on your program and the test cases can be considered as good. That is, if you have different mutants, these mutants should give you different results. That is different from whatever you have written in the test cases. So generally each mutant will have only one change. Okay, so whenever you are doing a logic slight logic changes, right, you have to make sure you will modify only single piece of code there. Do not in a single mutant do not include more than one changes. So to produce these mutants, what we can do is like we have the mutation operators. So the mutation operators is like you can replace the constant in the code, variable replacement can be done, arithmetic operator replacement, relational operator replacement, and go to label replacement. So you can use any of these mutants and create, you can change any of these things in your code and you can create mutants. Fine. So for example, we'll just a minute. Yeah. Say suppose we have this code segment, okay, that is input y, then you have sine function. Okay, x is equal to sine of y. You have to calculate this one. Then you have to print x. That means you have to take one value for y, calculate the sine of that y, and put it into a variable x, print the value of that particular x. Say you executed this program and say suppose you got wrong answer for this one. Then how do you debug? Where do you suspect the error is? Okay, so basically what you do, it is a simple program, right? You would suspect that there is a problem with the sine function, right? There is a problem with sine function, that's why it is not calculating the value properly. Then what you do, how do you debug this one? So basic thing is like, first you will check whether what you do, you just remove this sine function and you just check, or you replace this entire line with x is equal to y, right? Basic debugging, you just write x is equal to y, then again you print the value of x. That means you have taken one number for y, you move that value to x and you are printing x. At this time, if suppose this function is working correctly, then you will come to a conclusion that there is a problem with the sine function. Maybe you have missed the function name, you have given the wrong function name, something like that. You will come to a conclusion. So while debugging, what you have done to this program, actually you created a mutant of this particular program, right? For this program you created a mutant is this one, right? This statement, you changed this statement to this one, so this x is equal to y, it becomes a new mutant. Okay, so then as I said, you would suspect your sine function, right? And then you might realize that the sine function, it would not take the input in degrees, but it would take argument or the input in radians, and you will modify the program accordingly. So this is very common method of debugging by developers. So the next one is confirmation testing. So whenever a defect is reported in your software, it is the duty of the developer to debug that defect, and he has to change the code and he has to fix it. So whenever the developer indicates that the defect has been fixed, so it has to be confirmed by the tester that the defect has been actually removed, right? So that means the tester is confirming that the defect has been removed. So this is called as confirmation testing. Confirmation testing would be done by your testers or the test engineer. Okay, so why this confirmation testing has to be done? You have already informed the developer that there is a defect, and he has also confirmed you, right, that he has fixed the defect. Then why again the test engineer has to, or the tester has to go and verify the defect, right? So the testers, they have to trust the developers, but they have to verify the software is really defect free. It is one of the task of testers. Even if the developer says that the defect has fixed, it is the duty of the tester to go and test it whether the developer has actually removed the defect or not. Okay, the next one is regression testing. Okay, so when a defect is reported in the software, the developer has to debug it and he has to uh, make changes to the code, right? And then he has to fix the code. That means he has to fix the defect. So there might be a chance that whenever he is doing fixing the defect, that time there might be a chance that he has done some changes to the piece of code and it might have led to the another defect. So this defect may not be visible immediately. Okay, so whenever a change has been made to the source code, one has to ensure that there are no ill effects of the change on the other parts of the software. That means whenever the developer has, he has done some code changes, he has to ensure that that particular code change, whatever he has done, it will not break any other parts of the code. And this can be only done by doing the regression testing, and this regression testing would be done by the testers. Okay, right. The regression testing is done precisely to ensure that the change in one part of the software it has no ill effect on the other parts of the software. Okay, so this regression testing, it is always better to have it done after a round of system testing, and say suppose there are no defect coming up, that time you can have this regression testing. So what we basically do in the regression testing is like we execute the old test cases for basically for the core functionalities or the main functionalities of the software. Okay, at the end we will again retest or rerun the test cases for the core functionalities. So it will ensure or give the confidence that the code has not broken anywhere. Okay. Again, we should not get confused with the regression testing and retesting. So retesting is done to ensure that the fault is rectified or the defect is rectified by running the same test case repeatedly. But in the regression testing, what will happen? We have to, again, regression testing is done to ensure that the modification done, it does not cause any other defect in any other parts of the system, or it does not break any other code in the system. So in the regression testing, different test cases would be run. Okay, so that is the difference between regression testing and your retesting. That's it for today. We'll conclude our session. Thank you.